See the next question. Yes, here 0 is less than a is less than 1. So which means a is lies in between 0 and 1. So which function that is? Increasing function or decreasing function? Yes, that is decreasing function only. Okay, and here x is greater than y. Okay, here 0 is less than a less than 1. And here x is greater than y. X is greater than y. Then here what is that condition, ma? While you are applying that logarithmic functions log x to the base a and here log y to the base a. So here this is increasing function or decreasing function? Decreasing function. While you are writing the decreasing functions, the signs will become changed or there is no change in its sign. Decreasing function means automatically signs will be changed. So in between x and y, which symbol is there? Greater than is there. So which symbol here will come? Yes, less than symbol will come. Okay, why? Because this is a decreasing function. Decreasing function. Okay, so that's why here there is a change in its sign. For example, here less than is there means here greater than symbol will come. Okay, so which option is correct? Yes, log x to the base a is less than log y to the base a. Option B is correct here. Okay, children, see that next question. Yes, this is also like that only. 0 is less than a is less than 1, which means a is lies in between 0 and 1. A is lies in between 0 and 1. And here something missed here. Here actually missing is there. So that is log x to the base a is greater than p. That is the question. Just change that. So here a is lies in between 0 and 1. Then here log x to the base a is greater than p. So here a is lies in between 0 and 1. So which function it is? Increasing function or decreasing function? Decreasing function only, no? So decreasing function means there is a change in its sign or not? Yes, we know that log x to the base a is greater than a power p means actually x is greater than a power p. X is greater than a power p if it is a increasing function. But here this is decreasing function, no. So here greater than symbol is there. So we will get it as less than symbol. Okay, greater than symbol is there. So that's why here less than symbol will come. Okay, so that's why here x less than. X less than means here it is there. So we can apply that 0 is less than x less than a power p. So option C is correct here. Okay, children, see that next question and the last question. Yes, 0 is less than a is less than 1. So again here this is a decreasing function. Just observe that all the problems given based on the decreasing functions. So a is lies in between 0 and 1. And the condition, logarithmic condition, log x to the base a is less than p. Again mistake is there. Here the question is 0 is less than log x to the base a is less than p. Okay, that is the question. Now apply that. 0 is less than log x to the base a is less than p. Okay, previous while we discussed about that conditions, at that time I told you how to write that 0. 0 we can write it as log 1 to the base a is less than log x to the base a is less than, we can write it as log a power p to the base a. Yes or no? Okay, so here remove that all the logarithmic values. 1 is less than, here a power x means log to the base a we have to remove, no. So x is less than a power p. But here this is decreasing function. Decreasing function means we have to change the sign. So we have to change this one as 1 is greater than, x is greater than a power p. 1 is greater than, x is greater than a power p. Why? Because this is a decreasing function. Why? Because the condition they given as decreasing function condition they given here. Okay, a is lies in between 0 and 1, no. So that is decreasing function. So that's why we have to change the sign. 1 is greater than, x is greater than a power p. So that option like this not given, no. So we can write this one as in reverse order. A power p is less than, x is less than 1. Okay, in any order we can write, no. This one only we can write it as a power p is less than, x is less than 1. So that option is there. So which option is correct? Yes, option B is correct here. Okay children, so up to here all the problems completed from that worksheet 3 also. So here these conditions are very important. So first follow that conditions video, after that only see this, do that all the problems from worksheet 3, then only you can understand it very well. Okay children, so in that next video we will discuss about that next concept 4 from your textbook. Okay, from your material concept 4 they given on that types of logarithms. Okay, and how they can divide that logarithms. Okay, thank you children. Hi children, in that previous video we discussed the problems from that worksheet 3, that is depends on that conditions which are increasing functions and decreasing functions of logarithms. So in this video we are going to discuss about that types of logarithms. So in that first video I told you about that types of logarithms, but once again see here in concept 4 they given, the first one is natural logarithms. Natural logarithms, and the second one is common logarithms. Okay, so here we have how many types? 2 types. So one is a natural logarithm, another one is a common logarithm. So what about that natural logarithm, ma'am? Here the base of the logarithm is e. The base of the logarithm is e, then we will call that logarithms are natural logarithms. Okay, if the base of the logarithm is 10, if the base of the logarithm is 10, then we will call that logarithms as common logarithms. So already we defined that some logarithm questions already we derived, no? So in that one we used that base as 10. So those all that logarithms are known as common logarithms. If the base is e there, base e is there, then we will call that logarithm as natural logarithm. Base 10 is there means common logarithm. So what is the another name of natural logarithm? That is Napier logarithms. Okay, one of the scientists Napier, he given that logarithmic table. So that's why we will call that natural logarithms also known as Napier logarithms. And what we will call that common logarithms? This one is known as Briggs logarithms. Okay, common logarithms also known as Briggs logarithms. And we will call another name also there, that is decade. Decade logarithms. Why? Because here base is 10. 10 is there means that's why decade logarithms also we will call this one. Okay, so first one is natural logarithms and the next one is common logarithms. If that log like this they given means log, L-O-G they given means that is common logarithm. For that natural logarithm they will give that Ln. Ln means that is natural logarithm. Log like this given means that is common logarithm, and here the base is 10 and here the base is e. Understood, ma? What is the difference between natural logarithms and common logarithms? Yes. So after that, so children, up to now we are discussing about that logarithms. So what about the logarithms? Actually I told you that logarithms defined for only positive real numbers. So we are writing here, for example, log 10 to the base 10 is equals to 1. We know that. Why? Because 10 to the power of 1 is equal to 10. Okay, some point values also we are getting, no? So that values, for example, here log 2 base 10. So those values where we can find? Actually we have that logarithmic table. Okay, backside of textbook sometimes they given that logarithms. Have you seen those all? If you didn't see means once you go and see that logarithmic table. Okay, there they will give that all the values, anti-logarithms and logarithmic values also they will give. Okay, by using that logarithmic values we can find that any value. Log 2 base 10, log 3 base 10, any value we can find that. Okay. So here after completion of natural logarithms and common logarithms they given here one of the important concept, that is the integral part of a logarithmic value of a number. Logarithmic value of a number is called characteristic. Okay, the integral part of a logarithmic value of a number is called characteristic, and the decimal part is called, mantissa. Decimal part is called mantissa. Okay, here two words they given, new words. What are those? One is characteristic, another one is mantissa. So what about the characteristic and what about that mantissa? So characteristic means, for example, here 3.0567. One of the logarithmic value is 3.0567 something. Okay, so here integral part is there and decimal part is there, no? So in this value, in this logarithmic, this is the logarithmic value of some number. Okay, that number logarithmic value is 3.0567. So here integral part 3 is called characteristic and 0567, this decimal part is called mantissa. Decimal part is called mantissa. Okay, so here how to find that characteristic of that any number? For example, here that number is integral. So just like that, log 729 to the base 10. So what is the characteristic of this value? So here we don't know what is the exact value, what is the decimal value of this one. So here how to find that characteristic? So for this type of questions, how to find means, here n is an integer. N is integer only, no, here. So here k is number of digits of an integer. K is number of digits of an integer. So k is number of digits. Number of digits of n. So here n is equals to 729. Did you understand? K is number of digits of n. N means here 729. Okay, so how to find that characteristic? Characteristic of log 729 to the base 10. Here the formula is k minus 1. What is the formula? K minus 1. So here k is equals to number of digits of n. So number of digits 1, 2, 3. So 3 minus 1, which is equals to 2. So 2 is the characteristic. So while you are finding that, if you observe the value of log 729 to the base 10 in logarithmic table, okay, in that table you will have that value 2 point something you will get. Okay, 2 point something. So in the 2 point something, 2 is the integral value, no? So 2 we will call it as characteristic. And point something is there, no? That is the decimal part. So the decimal part is called mantissa. Did you understand that? So like that only I will tell you one more example. Characteristic of log 24356 to the base 10. So what is the characteristic here? Again k minus 1 formula. K means how many digits are there here? 5 digits there. So 5 minus 1, so which is equals to 4. Okay, number of digits means k. And here characteristic means number of digits minus 1. So k minus 1 is the formula. So like that only log of here 324 to the base 10. So what is that characteristic here? 1, 2, 3. So 3 minus 1 is 2 is the characteristic. Did you understand? So like that only log of 1665 to the base 10. So here the characteristic is 1, 2, 3, 4. 4 minus 1. So characteristic is 3. So mantissa means 3 point something will be there, no? That something will be that mantissa. Did you understand, children? So like this way we have to find that characteristics of that given numbers like this logarithmic values. I'll tell you one more thing. For example, here log of 0.0567 to the base 10. Here characteristic required. Find that characteristic. Previous one integer values they given, so easily we can find that k minus 1 formula. Like this decimal values they given means how to find that characteristic. So here we have to check that decimal point after number of zeros. Number of zeros lie in between lie in between decimal point, lie in between decimal point and the first significant digit, and the first significant digit, significant digit plus 1 whole bar. Okay, once see this characteristic how to find means number of zeros lie in between decimal point. So decimal point, here decimal point is there and the first significant digit is 5, no? So in between decimal point and 5, in between decimal point and 5, how many zeros are there? Okay, here only 1 0 is there. So 1 plus 1. 1 plus 1 which is equals to 2. Here we have to write it as 2 bar. Okay, why? Because this is for that decimal points, no? So that's why here 1 plus 1 2 bar. Clear? I'll tell you one more example. Log 0.000456 to the base 10. So what is the characteristic? Yes, point after and the first significant digit before, how many zeros are there? 1 2 3. So here 3 plus 1 4 bar. Okay, I'll tell you one more example. Okay, see here, log of 3.00502 to the base 10. Like that one of the values there. So what is the characteristic? So here what I said, decimal point after how many zeros are there? Before that first significant digit. So what is the first significant? Significant means 1 to 9. All the digits are significant digits. So already we know that. 0 is insignificant digit. Why? Because 0 is insignificant. 1 to 9 all the digits are significant. Significance means which have value. Which has a value. Which doesn't have a value. 0 doesn't have a value, no? So that is insignificant. Significant means which symbols are having that value. So which means 1 to 9 are significant digits. Already we discussed in that first concept in number system. I told you that digits 0 to 9 are called digits. 0 is called insignificant digit and 1 to 9 are called significant digits. So that word we have to use here again. Okay, so here we should not take this one, we should not take this 0. Why? Because first significant digit before how many zeros are there? Those zeros only we have to calculate. So here how many zeros are there? 2 zeros. So 2 plus 1 is 3 bar. Okay, and one more thing, log 3.5643 to the base 10. What is the characteristic? Okay, here nothing is there. Nothing is there means 0, no? How many zeros are there? Only? No zeros are there here. So 0 plus 1. So here that is 1 bar. Am I clear? Yes. So this is about that characteristic. Okay, children. So let us see that one more example related to mantissa. Okay. So log of 12.23 to the base 10 which is equals to 1.0838. 0838. Okay, actually this is example I am saying. If you observe this value in that logarithmic table, this value only you will get. Okay, children. So here 0838 is called mantissa. Okay, 0838 is called that mantissa. Okay, here this one if you multiply with 10 to the power of n, then you will get it as, if you multiply this one with 10, then what you will get? 1.223. 1.223, then here to the base 10 which is equals to 0.0838. Okay, so here if the significant digits are, number of digits are same here, 0838, here also 0838. Here all the digits 1.0838, 1 2 3 4 5. Here also 5 digits are there. Okay, so here also numbers are changed. same, but here decimal places only different. So for this type of logarithmic values, always mantissa is same, always having the same mantissa. Okay, if you multiply this one with 100, then also you will get the same mantissa here. Okay, so what is the mantissa here? 0838. Here also 0838 is that mantissa. Okay, clear children? So this is that concept 4. Depends on this one only, we have that one more exercise is there. So in that next video we will discuss about that all the problems related to concept 4. Okay, thank you children. So hi children. So in that previous video, before video we discussed about that concept 4, no? Common logarithms, natural logarithms as well as characteristic and mantissa. So depends on that, here one worksheet is there. So let us see that worksheet. So the integral part of the common logarithm of a number is called integral part of a number. Integral part what we will call? Yes, that is called characteristic. Okay, so totally theoretical only this worksheet. So see here next question. Yes. The logarithm of any number to itself as base. So just example, the logarithm of any number to the same number as the base itself. So what is the value? Log a to the base a, which means here log a and here base also same. Then what is that answer? Log a base a value is always equals to 1. So which option is correct? Yes, option A is correct here. Next. The logarithms of numbers having the same sequence of significant digits have the same. Already I told you that if you multiply with 10 or if you multiply with 100, if it is having that same sequence of that significant digits, same digits, number of digits are same. Okay, then it have that same mantissa. What we will get? It has a same mantissa. Next question. A logarithm table is divided into, table is divided into how many parts? Here we discussed about that characteristic and mantissa. So logarithmic table, everything is there in the decimal form only, no? So in the decimal form, the integral part is called characteristic and the decimal part is called mantissa. So how many parts? 2 parts. Okay, one is characteristic, another one is mantissa. Next question. The characteristic of the log 0.03. Yes, log 0.03. What is the characteristic? Yes, here this is decimal number, no? So how to find that characteristic? Point, decimal point after and the first significant digit before, how many zeros are there? So here how many zeros are there? Only 1 0. So we have to add 1. Okay, so 1 plus 1 is equals to 2 bar. 1 plus 1 is equal to 2 bar, but here in that options bar symbol is not given, so we can take it as 2 bar. Okay, we should not write it as a negative, so take this one as 2 bar. Okay children, so see that next question. So children, see that next 6th question. The number whose logarithm given means the logarithmic value they given. So what we will call that value means anti-logarithm or logarithm of antecedent. Okay, so what we will call that? Anti-logarithm. So next, the characteristic of the log 0.000581. So what is the characteristic here? Again decimal point after and the first significant digit before, how many zeros are there? 3 zeros are there. So 3 plus 1, which is equals to 4. Actually negative values, that's why they given here -4, but we have to write that one as a 4 bar. Okay, so that one only we have to write it as 4 bar, but options they given as -4, but we have to write this one as 4 bar. Okay, so next, common logarithm is also known as, what is another name of common logarithm? Yes, that is Briggs logarithm. The name is not there, and already I told you that decadic. Okay, decade or decadic logarithm. Why? Because here base is 10, so that's why. Next one. For common logarithms, the base is, common logarithms, what is the base? Yes, base is 10. Next, for natural logarithms, what is the base? Common logarithms base is 10, natural logarithms base is E. Base is E. So next one, John Napier prepared the logarithm tables to the base. So John Napier logarithms, what is the base here? John Napier prepared the logarithms tables to the base E. Option not there, so that is none. Okay, Napier logarithms means that is nothing but natural logarithms. So in that natural logarithms, what is the base? E only, no? So that's why. And the next one is the logarithms having base 10. Base 10 are called. Base 10 is there means which logarithms? Common logarithms or Briggs logarithms. Same question only, they are giving number of times but they are changing that sentences. Okay, but the meaning is same. And the next one is log mn to the base a equals to. So what is the formula here? Direct formula, mn to the base a. So product is there means log m to the base a plus log n to the base a. So which option is correct? Yes, option A is correct. Next, the decimal part of the common logarithm of a number is called decimal part. Integral part is called characteristic and the decimal part is called mantissa. So up to here all the problems completed, all the questions what they given in that worksheet 4, all the problems completed. Okay, so children, let us see that next some related to cumulative assessment is there. So that problems we will discuss in that next video. Okay, thank you children.